Yes, hello once again. Yes, the video was getting a bit blurry, so that's why I had to stop it and then redo it again. Okay, so I'll just continue from where I left off. Okay, so class declaration. Okay, yesterday's example, class employee, right? Public. This is the public access specifier. Now you see that the access specifier it ends with a colon, right? So this is like a label. Okay, you have seen that this colon in your class 11 also, right? Well, what is the use of that colon? Will you use that in switch case, right? Switch statement, and then switch construct, and then in go to labels, right? Go to statements. Okay, so here employee int employee code, right? Okay, and this character employee name, all these are your data members. Okay, and this void display, this is your member function. Okay, so it encapsulates both the data members and the member functions. Okay, so encapsulation, data hiding, yesterday in the previous video I explained to you. Okay, so just go through that. Okay, now what are members? Okay, members. So there are two kinds of members, okay, that are data members and member functions. So when we talk about the word members, keep in mind the data member and member functions. Okay, now members have a new attribute, visibility. Just as global variables are visible to all functions and local variables are not, individual members of a class can be made visible everywhere or not. Okay, what does it mean? We also discuss about global variables and local variables, right? Global variables, the variables which are declared before the main function, right? Okay, after the header file, right? So that is accessible by any functions, right? Any part of the program. And local variables means the variables which are declared in that function, definition, or in that function body, can be used only within that function body, right? We have also seen those examples of local variables. Okay, so are not individual members of a class can be made visible everywhere or not. Okay, now member visibility is determined by the visibility label, which label, so that is depends on your uh, this access specifier, public, private, protected. Okay, so the way you access local variables, okay, is through this access specifier, private, public, protected. Okay, now data members, now we come to data members. Okay, so data members of a class are exactly like the variables in a structure. Okay, so the variables in a class definition are called data members, and a class functions are called member functions. Okay, so here these are your data members, keep that in mind. Okay, these are your data members. So a class variable and function can have one of the three basic accessibility types. Public members are visible directly through an object, that means accessible by the object. Okay, so keep in mind that these data members, okay, this signifies the state of an object. Okay, you can say like the characteristics of an object. Okay, now what defines a student, right? When you have to write a program about student, what will you write about the student? Suppose class student, right? The name of the class is student. So what will you define about a student? His most obviously it will be his roll number, his name, age, subject, marks, like that, right? So that defines the state. Okay, so that is the data members, and that can be made as public, private, protected. So if it is private, right, okay, or if it is made public, okay, so depend on that security ways. Okay, so I hope you're clear about that data members. Okay, then So public members, okay, so once it is made public, this, okay, that means the object itself can access the object. When you talk about object, okay, class is different, object is different. Okay, a class is used to create an object. Okay, object is an instance of a class. So a class student, now to make it come alive, the class student, right? Okay, so what do? You create objects like std1, std2, std3. Now when you create that object, what happens? The compiler allocates memory space so that these are also variables. Okay, an object is also a variable, keep that in mind. Okay, so these variables uh, will occupy memory, okay, will be allocated memory. So using an object, you can access these variables to store the data. Okay, now again, so since these are also variables and objects also variables, right? So what is what is the need of an object, right? What is the need of an object, or why can't we use this directly? Okay, I'll explain that from this program. Okay, now coming back to the private members. Okay, private members are completely hidden, okay, only accessible within the class member functions. So private members is not accessible by its own object. So only the member function can access the private data members. Okay, so to access these data members, you can use object or you can use member functions. Okay, so member functions in this sense, like the calling function, call functions. Okay, so protected members behave like private members except that subclasses have direct access to them. Okay, so this will be discussed later on. Okay, now coming back to the member functions. Now member functions are functions defined within a class that acts on the data member in the class. Okay, we have already seen that the use of member function distinguishes a class from a struct. Okay, like I said, a structure did not have a member functions. Okay, so the following is the member function of the employee class, which includes some extra member functions than the previous example. Okay, so here, okay, so void display, this is your member functions. Okay, now based on that, okay, let's come back to object. Okay, so an instance of a class called an object must be created before you use it. This is because the class is like the plans for a house and the object is the actual house that has been built. Okay, so how do you declare an object? In the previous video also I have already shown you, right? So by using the class name, you can create the object. Okay, see, here is how you instantiate an object called emp of the class employee, right? So you can see the name is also very much similar with the class name. Okay, this is your class name employee, this is the object name. Okay, so this is how you declare an object. Okay, and when you declare this object, what happens? Okay, the memory is allocated for this object. Okay, so how do you access uh, so here in this case, see, you using the class, you can create different objects. Okay, employ emb, emb1, emb2, emb3, like that. Okay, so now in the note part here, it is written here, a class is a blueprint of an object. Okay, it reserves no memory space to data. Each object has its own data space. Okay, every object that is memory space is different from emb1, like that. Okay, an object is an instance of a class. An object contains variables and methods. Variables in this case is your data member. Methods, when you say methods, it means the member functions. Okay, so the values of variables define the state. Okay, so like I said, the state is your symbol variables. The state is your data members of the object. Okay, of the object. okay, not of the class. Okay, a class simply encapsulates the members of the object. Okay, and the method defines the behavior of the object. Okay, and the methods, that means the functions, define the behavior of the object. I hope you got it. Okay, now how do you access the class members? That also we have already seen by using the dot operators, right? Okay, the syntax here, the format is already given here. The syntax for accessing a class member is similar to that of accessing a member of a structure using the dot operator. In this case, the object name dot public data member name. Okay, object name, that is the object name, as in this case emp. Okay, dot public. So only when the data members, okay, these data members are made public, okay, as in this case public, okay, then only the object, this emp, can access the data members, these data members. Okay, so that is object name dot public data member name. That means suppose like emp dot emp code. Okay, that is provided the access specifier is public. Okay, in the next one, okay, object name dot public function member name. Okay, function member name, that means your member function. Okay, so this void display, you got it. Okay, so in that case, that means object name will be emp dot display. Okay, so I hope that you understood that. Okay, so here note that only the public members can be accessed, okay, outside the class specification. So only the public members can be accessed. Public members means what? Can be accessed outside the class specification. Private and protected class members can also be accessed by member functions that can be private or public. So this is very important. Okay, note that only the public members can be accessed outside the class specification. Now if you see in this program, okay, in the next page, okay, this is the class declaration. It ends here. Okay, it ends here. So this is the class employee, this is the opening bracket, this is the closing bracket, and here ends, terminate by semicolon. Okay, so this whole part is your class declaration, and this is your main function. So this is separate, keep that in mind. The compiler will only execute what is written within here, not within this, right? So how do you access this, right? Okay, now so this particular sentence, okay, only public members can be accessed outside the class specification. Okay, can be accessed outside the class specification. So meaning, how do you access these members, these data members and member functions? If it is made public, with you can access it with the object, you can also access with the member functions, right? But when an object is declared, like in here, okay, you can access it directly. So that is like this, emp code, right? So you are accessing this outside of the class declaration in the main function. Okay, in the main function, using the object, you are accessing the data members here, emp code. Okay, so outside, okay, outside of the class specification. Similarly, the member functions, the member function also is accessed outside. Okay, like this, using the object. What if suppose you cannot do access it, there are different ways of accessing it outside the class specification. Okay, the next program is also different. Okay, so when we come to that, I'll show you. Okay, now uh, similarly, okay, similarly, the function members are that are declared as public are accessible from outside the class specifications. Okay, these public functions can access private data members as well as private functions of a class. Okay, so that way. Okay, so here you can see the ways to access using the or the functions. Okay, emb dot display. Okay, now this is actually, okay, as this is actually what is this, the calling function. This is assigning the values. Okay, passing the values, passing the arguments using this function. Okay, member function. So we'll invoke member function display, which assigns values, okay, 100 to data member emp code, and two strings, Miss Sujata and pgt computer to ename. Okay, so this is what I said is assigning the values. Okay, this will assign the value 100 to the this emp code, okay, and Sujata to emp name, like that. Okay, so this is how you can assign directly using the function. Okay, now member function declaration. Okay, so how do you declare a function? Now this is also very important. Okay, so you understand this very nicely. Okay, and then writing this uh, object and classes program will be become much easier for you. Okay, now inside the class declaration or outside using scope resolution operator. So this scope resolution operator is a new thing. Okay, as you can see here, you use two columns, okay, or four dots. Okay, so what it does, okay, so first one is inside the class. Okay, we have already seen that. Okay, now this sentence, okay, inside a class the body of the function is declared using the beginning braces and ending braces. Okay, if the member functions are defined inside the class definition, then there is no need for function prototype or function declaration. Okay, you know that when we have to use a function, okay, in a program, you have to declare it, a prototype, right? So that is to prevent error mismatch, right? So similarly in classes and object also, you when if you're using a function, you need to have a function prototype declaration. Okay, now, so what is this function prototype? Okay, now in the case of this one, in the case of this particular example here, this is your function void display. This is function definition. As you can see that the within this opening and closing bracket, this denotes the function body, right? It does not end with a semicolon, so this is the function body, and so this is your function definition. Okay, or this is your call function. Okay, so now when it is declared inside the class, or see, if members what is that, yes, if member functions, yes, if member functions are defined inside the class definition, okay, are defined inside the class definition, then there is no need for function prototype. So since here the member functions are defined inside the class declaration, so this is can be considered as the function prototype, so there is no need for a function prototype declaration. Okay, so inside the class, okay, so this is inside the class. So inside the class, this function has already been defined. Okay, so now coming back to this program. Now if you look at this program, okay, always the program starts with the header file. Okay, here it is, standard input output. Okay, studio.h. Okay, so here the class, the keyword, the class name is employee user defined data type. Okay, here the access specifier is public. Okay, now is public by default. If this access specifier is not written, okay, then by default these members, this data members or the member functions, okay, will be made private. Okay, by default it is private, but if it is specified here public, that means all of this uh, will become public. Okay, so here employee code, employee name, employee designation, employee salary, okay, your data members, and then the member functions just above here, above this void display. Okay, nothing is written here, right? So that means this followed by this label, that means this void display, this member function is also public. Okay, so now this is your function definition. Okay, so this is similar to your function prototype declaration. Okay, so when you are defining this inside the class body, so there is no need of function prototype. In the next example, you will see that function prototype has been declared inside the class. Okay, so you will see the difference between this program and the other program. You will see some difference. Okay, so it ends here. Okay, now inside this function definition, you can see simple cout statement. Okay, so this cout statement will simply run, and it will display the employee code from this variable: employee name, employee designation, employee salary. Okay, now in the main function, you can see the class object declaration. Okay, using the class name employee, you are creating an object, you are declaring an object called as emp. Okay, so here you are see, after that, what is the next step? You are initializing the variables. Okay, emp, using the dot operator, emp code equals to 100. So you are assigning the value 100 to this emp code. Okay, similarly, okay, so you are assigning the value 100 to this emp code, and it is stored in here. But okay, so coming back to the why we have to use an object, right? Why can't we simply directly assign the value to this, right? So what will happen now? The the advantage of classes and object is, okay, reusability, code reusability. You can reuse these data these members again and again in the program, right? And you can create objects as many as you want using the class, right? So what happens is, same like structure, to access these members you need a structure variable. So here also, to access these variables you need an object. Okay, so when you are creating an object like this to store the data, emp code equals to 100. Now you're assigning the value 100 to this emp code, but in fact, okay, you are not directly storing the value in this emp code variable. Okay, so a memory space will be created for this. Okay, but if suppose you create another object, so it will be, suppose, emp1, so it will be emp code equals to 100, and the next one will be, suppose, emp1 code equals to 101. Okay, so you see that you're reusing this variable emp code twice for two objects, one for object emp and for another object emp1, right? So similarly for students also, right? Suppose like student stud std1 std2, so student roll number, student name, right? So that way what you can do is that you can reuse these data members to create as many student details as per the program wish. I hope you're getting understood. Okay, so directly you cannot assign there, you cannot directly assign here the value. Okay, if you write here int emp code equals to 100, that will result in error. Okay, so that nullifies the whole concept of classes and object. Okay, so for in that case, classes and object is of no becomes of no use at all. Okay, so the if you do it like this, if you do int emp code equals to 100, then what will happen is that you can use this emp code variable only once. Okay, a variable can store only one value at a time, right? But using the object, depending on how many objects created, you can reuse this variable 2, 3, 4 times, 100 times. Okay, I hope you got it. Okay, now next one is, the next line statement is strcpy, string copy. Okay, we have seen this in class 11. Yes, right? string manipulation functions. Okay, so this is a string manipulation function. Okay, so what it does is, okay, if you remember that in arrays chapter and then in structure chapter, right, string array, and in structure chapters also we could accept string data, right? So we use this string copy, right? So how do you so this is assigning, right? You're assigning this string value to this emb name. You cannot same like this you have written here, emb code equals to 100, right? This is an integer value. You cannot write down like this, emb name equals to Miss Sujata. It's not possible like that, right? Because this Miss dot Sujata, this is a string, this is multiple characters, right? Okay, so it has to be enclosed in double quotes. So the only way to assign this value Miss Sujata, this data, to emb name is using this string copy. Okay, and the syntax of the format of this string copy is s1 comma s2, right? So the contents of s2 is copied onto s1. You got it? So using this format, okay, Miss Suchada, which is written within double quotes, okay, will be copied to this emb name. Okay, similarly the next line also, pgd computer will be copied to emb designation. Okay, so you can see that to access the data members, you are using the object name, not the class name. Okay, the class name is used only to create the object. Okay, now after that, okay, this for loop is there. Now see out here is the employee information, the for loop in I equals to 0. So this is the for loop initialization, test the condition as long as it runs equals to 32 times. Okay, iteration incrementing. Okay, I equals to I plus 1. I've already explained this for loop to you. Okay, I hope all of you knows this. Okay, so what is the use of this for loop? Only this cout statement. Okay, so as long as this for loop condition, uh, this repetition takes place, cout, okay, within this double quotes, this equal to will be printed out. So that's why in this here is the employee information, this equal to is printed out 32 times. Okay, so this is not necessary. Okay, however, it's just for program readability, for understanding. Okay, so the user can understand the difference between here and this area. Okay, so now after that, emb.display, so the member functions, call member function. Now this is your calling function. Okay, so always in a function, you just remember a function prototype is there, calling function, call function. That is the only difference. Okay, so this is your calling function. So this calling function, what it does,